Assalamu alaikum, dear student. Welcome to the online class. This is your MMA sir. The topics that I should focus in today's class basically electrophilic substitution reaction. So, for the first time, I would like to say something about the definition of electrophilic substitution reaction. Reaction where substitution in aromatic compound is occurred by an electrophile is called electrophilic substitution. So again I said reaction where substitution in aromatic compound. So this is an important point. Normally electrophilic substitution reaction is happened in aromatic compound, say benzene. So reaction where substitution in aromatic compound is occurred by an electrophile. Substitution should be occurred by an electrophile if it wants to be a electrophilic substitution reaction. So this type of reaction is called electrophilic substitution reaction. So here this is an important point to understand what do you mean by electrophile. Electrophile, any organic reagent which has deficiency of electron and has attraction to electron, it's called electrophile. So electrophile is basically any organic reagent which has deficiency of electron and has attraction to electron, it's called electrophile. You can consider this example: methyl plus, chlorine plus, acyl plus, nitronium plus, SO3. All of them have basically deficiency of electron. Okay, due to the deficiency of electron, they have greater attraction to the electron, and that's why they are called electrophile. So I hope you understand. Electrophilic substitution reaction you can divide by 5 types. First one is alkylation, and second one is acylation, third one chlorination, fourth one nitration, and last one is sulfonation. The electrophile that should be used in case of particular electrophilic substitution reaction, you can use alkylation electrophile methyl plus, you can use acylation CH3CO plus. In case of chlorination you can use Cl plus. In case of nitration you can use as electrophile nitronium ion. In case of sulfonation you can use as electrophile SO3. So these are the electrophile that should be used during the time of 5 types of electrophilic substitution reaction. So I hope you understand about electrophilic substitution reaction. So dear student, I have written here 4 types of electrophilic substitution reaction. First one is alkylation, and second one is acylation, and third one is chlorination, and last one is nitration. These are basically the reaction, just the reaction, 4 types of electrophilic substitution reaction. We know very well during the time of alkylation, benzene should react with alkyl chloride in presence of anhydride AlCl3 to produce toluene or methyl benzene as well as hydrochloric acid. In case of acylation, benzene should react with ethanoyl chloride in presence of anhydride AlCl3 to produce acetophenone as well as hydrochloric acid. In case of chlorination, benzene should react with chlorine in presence of anhydride AlCl3 to produce chlorobenzene as well as hydrochloric acid. In case of nitration, benzene should react with nitric acid in presence of sulfuric acid to produce nitrobenzene as well as water. So during the time of alkylation, acylation and chlorination, the catalyst that you should be used is same. In case of alkylation, acylation, chlorination, the catalyst that you should be used is same. In each of the case, you have to use the catalyst anhydride AlCl3, anhydride AlCl3, anhydride AlCl3. So I hope you understand these 4 types of electrophilic substitution reaction. During the time of alkylation, what is the product that should be produced? Is basically toluene or methyl benzene. In case of acylation, the product that should be produced is acetophenone. Acetophenone. In case of chlorination, the product that is produced is chlorobenzene. And in case of nitration, the product that should be produced is basically nitrobenzene. Now I would like to draw the figure or reaction of sulfonation. What happened during the time of sulfonation? Sulfonation. During the time of sulfonation, benzene should react with sulfuric acid in presence of sulfur trichloride with a little bit heat. Then it produces this acid, which one is called benzene sulfonic acid. Benzene sulfonic acid. So I hope you understand. So during the time of sulfonation, benzene should react with sulfuric acid in presence of sulfur trioxide to produce benzene sulfonic acid. So these are normally the general reactions of electrophilic substitution reaction. 5 types of electrophilic substitution reaction. So dear student, now about alkylation. I have already told about this reaction. Now I would like to say something about the mechanism of alkylation reaction. The first step of the mechanism of alkylation reaction is basically formation of electrophile. During the time of formation of electrophile, methyl chloride should react with anhydride AlCl3, which one is basically here act as a catalyst. You have to remember the point that AlCl3 is basically itself is a Lewis acid. As it is a Lewis acid, it should have the capability to accept a lone pair of electron because it has a deficiency of electron. Again, chlorine here acts as the electronegative element, and for this reason, this chlorine atom should try to remove itself from this compound by gaining in the bonding pair of electron, and by this way it converts negative charge Cl minus. When it turns into Cl minus, this Cl minus as a ligand should donate a lone pair of electron to this compound AlCl3, and by this way there is a coordination bond in between AlCl3 and chlorine ion, and by this way there must be produced AlCl4 minus this molecule, this ion. Okay, when this ion is produced, this methyl chloride, methyl plus this electrophile should be produced. So this one is basically the first step to the for the formation of electrophile. Now the second step. During the time of second step, basically it involves with the electrophilic attack to the benzene ring. So in the time of second step, this electrophile should be attacked to the benzene ring. So as it holds positive charge, so it should attack to the carbon, which carbon is basically in negative charge. So you have already seen there is a bond, there is a pi bond. You know pi bond is comparatively weak bond. So there must be happened here heterolytic fission. Again say there must be happened here heterolytic fission when this electrophile should be attacked to this carbon atom. When this electrophile attack to this carbon atom, there must be occurred an heterolytic fission. By this way this carbon will be negative in charge and this carbon will be positive in charge. We know very well when there occur a heterolytic fission, one carbon become negative in charge and another carbon become positive in charge. So at the same time this carbon will be negative and this carbon will be positive. So when a negative charge and positive charge by a negative charge and positive charge there is a possible to form a bond, you know. So when this carbon become negative and this carbon become positive, when they come closer to each other, so there must possible to form a bond like this way. This is basically the bond. Positive charge, this carbon was negative, and by this way this bond is produced, as this carbon negative and this carbon should be positive carbon. So this structure you can produce. When this carbon become positive, this adjacent carbon have also the tendency to become negative. If it becomes negative, then there is a chance to produce a bond also here. And for basically to form a bond, this carbon wants to be negative in charge, and for this reason these bonds there also happen heterolytic fission, and by this way this carbon will be negative and this carbon positive, and they produce a bond here, and this carbon will be positive in charge. As this carbon is negative, so this carbon should be positive. There also occurred here heterolytic fission. So after this, what happened? These positive charge and these negative charge form a bond. When this carbon will become negative, this carbon should be positive. So I have written here positive charge. Okay, so this type of structure can be produced here. Okay, okay, when this carbon become positive in charge, so this carbon has also the tendency to become itself negative in charge, to form a bond in here, negative positive, a bond in here. So there must be occurred another heterolytic fission in this bond. When this carbon will be negative, to form a bond here, this carbon will be positive in charge. So I hope you understand. Negative charge and positive charge, there is a bond. Okay, so by this way you will get three structure like this way. So what happened here? When electrophile attract here, this carbon for the first time become positive, and after becoming this carbon positive, this carbon will be negative, and there must be produced a bond, and this carbon will be also positive. After this carbon will be positive, this carbon will be negative, to form a bond, to form this bond here, and after formation of this bond, this carbon will be positive. So there is a movement of positive charge. Just you look at the structure please. For the first time positive charge in here, and second time positive charge is here, and for the last time positive charge is here. So first time positive charge here, then here, and then here. So there is a movement of positive charge. Basically this one is called resonance effect, and by this way you will get here three structure, and these three structure you can write down like this way. Which one is called sigma complex? Which one is called sigma complex? So you can write down this sigma complex structure, which one is equivalent to these three structure. Okay, so when electrophile attack to the benzene ring, then you will get a structure, which structure is called sigma complex structure. And the last step is deprotonation. Protonation. This is very easy step. Deprotonation should be occurred here when you use here AlCl4 minus here, then deprotonation will be happened. You have already seen here there is a latency of positive charge, there is a latency of electron here. Basically there is a latency of electron here basically in this sigma complex structure. When a proton should be eliminated from here, then it will give this structure a electron basically. Then electron itself is a negative in charge and there is a positive charge inside that benzene ring. Then both these negative charge and positive charge will cancel each with other, and by this way this proton will be eliminated from here, and this proton should be substituted by this methyl group, and by this way electrophilic substitution is happened here. So then you will get this product, and AlCl3 Cl minus will be formed HCl bond will be formed hydrochloric acid by forming a bond with proton, and the catalyst will be AlCl3. You will get intact at the rest of the reaction. So this is basically the way to understand about alkylation reaction. So dear student, this is basically the mechanism of alkylation. You have already seen on the board. The mechanism of acylation and chlorination should be same, top to bottom same, just like as alkylation. There is just a change in electrophile. In case of alkylation, you know electrophile is methyl plus, okay, but in case of acylation, electrophile is CH3CO plus, acyl plus, okay. Just you have to give you have to replace CH3 by CH3CO. In this mechanism where you will have CH3 group, you just replace this CH3 group by CH3CO during the time of acylation, like this way. Acylation. You just replace CH3 by CH3CO. Do not need to change in anymore. So I should erase CH3. CH3 should be replaced by CH3CO. CH3COCl. এখানে Cl লিখব. Product should be CH3C Ac2phenol as well as HCl will be produced here, you know. CH3CO, CH3CO, COCH3 as electrophile. It will attack to the benzene ring, and mechanism should be same like alkylation. COCH3, 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 then COCH3, then product should be COCH3 Ac2phenol, and everything is top to bottom just like as alkylation reaction. Just you should replace CH3 group by CH3CO group. Now what happened during the time of chlorination? During the time of chlorination, this is also just same to the reaction of alkylation or acylation. Just you should have to replace CH3CO or CH3 group by Cl plus. So you have to give here chlorine, you know, chlorine, and CH3 Cu group just you replace by Cl, then everything will be same. Cl2 Cl plus electrophile. Cl plus Cl plus Cl 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 Cl. So chlorobenzene will be produced here. Okay, dear student, now I would like to say something about sulfonation reaction. Sulfonation reaction is basically occurred in presence of sulfuric acid. When sulfuric acid is react with benzene, then they produce sulfonic acid. So this is basically sulfonation reaction. Now the reaction mechanism. The first step of the reaction mechanism, there must be produced sulfur trioxide as electrophile. You know, to produce sulfur trioxide, the mechanism is basically like this. Two sulfuric acid molecule, for the first time you have to take here, due to electronegativity, which bond will be broken as which minus, and a proton also should be eliminated from this compound. Then the proton and which minus should be connected each with other and form water molecule. Then sulfur trioxide will be released as neutral sulfur trioxide molecule, and from here there must be eliminated a proton from sulfuric acid, and this is this proton. And when a proton is eliminated from sulfuric acid, then there must be produced a bisulfate ion. So during the time of formation of electrophile sulfur trioxide, there must be produced water molecule, proton, and bisulfate ion as well. So now the second step. In the second step, sulfur trioxide should be attached to the benzene ring as a electrophile. The structure of sulfur trioxide is like this. You know, here oxygen is electronegative, and that's why oxygen become partially negative. I have written here del minus, that means partially negative, and sulfur should be partially positive. And for this reason, a sulfur trioxide connects as a electrophile. Then sulfur should be attached to the benzene ring and this carbon. That there happens this mechanism. You have already known this mechanism. And as sulfur attached with this carbon, sulfur is positive and this carbon is negative, and this carbon is negative, and for this reason sulfur trioxide minus I have written. And so this should be the mechanism. I have already discussed for a number of times this mechanism, so I do not interest to say something about this. Okay, when sulfur trioxide attached to this benzene ring, then there produces sigma complex that you have already seen in the board. After the formation of sigma complex, then there must be happened here deprotonation. To happen deprotonation, you must have to give here bisulfate ion, this bisulfate ion, and when you give here bisulfate ion, then a proton should be eliminated from this compound, and this should be connected with this bisulfate ion and form a sulfuric acid molecule and remain this compound. And by this way, is sulfur, the hydrogen is replaced by this sulfate ion. Okay, after formation of this compound, then there must be needed a proton. You have already seen in the board that sulfur trioxide, there is also hydrogen is present here. So the name of this compound is basically benzene sulfonic acid. So a proton should be come here. This proton should be come here to connect with this sulfur trioxide, and thus they form a bond basically, and by this way this compound become neutral and form benzene sulfonic acid as product. So dear student, now nitration. During the time of nitration, benzene should react with nitric acid in presence of sulfuric acid to produce nitrobenzene as well as water. So first step is basically the mechanism is basically involved with the formation of electrophile. So during the time of formation of electrophile, this nitric acid should react with sulfuric acid. Here Oxygen is electronegative element. For this reason, which bond should be eliminated from this compound as a which minus, and they are also produce a proton from this sulfuric acid molecule. This proton and OH minus will combine each with other and form a water molecule, and by this way NO2 will be positive in charge and form NO2 plus nitrogen ion, which one is basically here act as a electrophile, and as well as a bisulfate ion will be produced also, because a proton is eliminated from this compound. As a proton is eliminated from this compound, so this compound should be converted into bisulfate ion. In the second step, electrophile, as nitrogen ion should be attached to this benzene ring, and everything will be just like as before, and there also produces sigma complex here. After formation of sigma complex, a proton should be eliminated from this compound and form sulfuric acid. When a proton is eliminated from this compound, a nitronium ion as a nucleophile, as a electrophile is substituted, is replaced this proton and form this compound, the product nitrobenzene. So this is basically the way to understand nitration reaction. So like this way we can easily understand all the 5 types of electrophilic substitution reaction: alkylation, acylation, chlorination. If you know alkylation, then this is really easy to understand acylation and chlorination too. I have already discussed about this matter. Then you have to understand sulfonation and nitration. Among these 5 types of electrophilic substitution reaction, you must have to remember this point: alkylation, nitration and sulfonation. Especially sulfonation and nitration is very important reaction, so you have to focus each and every reaction. Okay.